Hi, I'm Ryan Baker, and this is Big Day in Education. Welcome to week 3 of the course, Behavior Detection. So over the last 2 weeks, we've discussed prediction modeling. And this week, we're going to focus on a type of prediction model called behavior detectors.
So what are behavior detectors? Behavior detectors are automated models that can infer from a student's interaction or logs whether a student's behaving in a certain way. And we discussed examples of this, self-regulated learning behaviors, in the Zhang et al. Case study in week 1.
The goal of behavior detection is to infer meaningful and complex behaviors from logs or in real time, with two goals. First of all, so that we can study those behaviors more deeply. For example, how do the behaviors correlate with learning, and what are their antecedents? And second, so we can identify when they occur in order to intervene. People have detected a lot of behaviors in educational data mining.
So people have detected disengaged behaviors like gaming a system, trying to get through the learning system without having to learn the material. For example, a student might type 1 and it's wrong, and they type 2 and it's wrong, and they type 3 and it's wrong, and they go on all the way to 35. Off-task behavior. A student might just simply cease working in the system at all. Carelessness. A student might keep working, but they might put in so little effort that they get wrong answers on stuff they know. Inexplicable behavior, also called WTF behavior. It stands for without thinking fastidiously, and it consists of behavior that makes you go, WTF. This includes things like students in a virtual world where you're supposed to be investigating why patients are getting sick, going out to the desert and picking up a virtual cactus and dropping it on the virtual patient. Stop out. This, in MOOCs, stop out is framed as just quitting the MOOC entirely, but in intelligent tutoring systems and related systems, stop out is construed as quitting on a problem set and not coming back to the problem set without having completed it. There's been a lot of work to detect SRL, self-regulated learning behaviors. SRL behaviors include things like help avoidance, when a student needs help but won't ask for it. Persistence, when a student is struggling but they keep at the task until they get it. The negative side of persistence, wheel spinning, where a student is just not making any progress and they don't do anything to help themselves start to make progress again. Unscaffolded self-explanation. Sometimes students will actually take a math problem and a learning system that will give you the answer at the end, and they can't figure it out. They'll click through the end of the hints, but instead of gaming a system and just moving on, they'll actually pause and self-explain why that's the right answer. Computational thinking strategies of various types. There's also been work to detect teacher strategic behaviors like curriculum planning and proactive remediation. Proactive remediation is when a teacher will use the reports from a learning system to decide which students need help, and then they'll go over and talk to those students. And Miller showed that you can detect that actually from the students' logs when a teacher's doing that. Classroom discussion management strategies, increasingly from transcripts of classrooms or even videos. Asking authentic questions. Are the teachers asking authentic questions or decontextualized ones? And uptake of student ideas. When a student gives an idea, does the teacher actually respond to it and build the conversation around it, or do they just move on? And incidentally, a related problem to behavior detection is sensor-free affect detection, detecting a student's emotion and context from their interaction. It's not quite the same conceptually, because with behavior detection, you are detecting something that you can directly see. With affect, you can't directly see it, you're inferring it from the behavior. But the methods that you use to detect it turn out to be quite similar. And people have done work to detect boredom, confusion, frustration, engaged concentration, delight, other affective states as well, to smaller incidents. Another related problem is analysis of student usage of learning management systems and MOOCs, where researchers will study online learning behaviors. This is typically not the same methods and processes, though, that I'll be discussing in the next lecture. More often, researchers in this area have looked to predict outcomes from relatively straightforward behaviors, and that's due to what's visible in the log files. Access to resources rather than the kind of thinking processes that can be made visible through complex learning activities. That said, there's been lots of great prediction modeling research in this area, predicting and analyzing outcomes based on when and how much students use videos, quizzes, labs, forums, and other resources.
So for ground truth, where do you get the prediction labels? Behavior labels are noisy. There's no perfect way to get indicators of student behavior. That's why we say it's not truth, it's ground truth. Another way to think of it. In some fields, there are gold standard measures. as good as gold. With behavior detection, we have to work with bronze standard measures, gold's less expensive cousin. Is this a problem? Not really. It does, however, limit how good we can realistically expect our models to be. If your training labels have an inter-rater agreement of kappa of 0.62, you should probably not expect or want your detector to have kappa of 0.75. Because if you get a better kappa for your detector than your training labels, it means your model is fitting to your coders, not to the construct you actually are looking for. There's a lot of sources of ground truth for behavior. Some of them include self-report, field observations, hand coding of logs, aka text replays, and video coding. The advantages and disadvantages of these methods are somewhat outside the scope of this course. But an important note, no matter which coding method you use, try to make sure that the reliability and quality of your labels is as high as feasible, while at the same time noting that 1,000 codes with kappa of 0.5 might still be better than 100 codes with kappa of 0.8. In data mining, as in many other areas, quantity has a quality all its own. Now, one other thing to note is that it can be harder to get high reliability for video coding than other methods. This might seem a bit non-intuitive because people tend to think it's video, you have it all to see. But in fact, issues of lighting, of camera resolution, of occlusion tend to make it significantly harder to get good inter-rater reliability for video than for field coding, for example. In the remainder of this week, we're going to discuss feature engineering for behavior detection and knowledge engineering versus data mining. In the next lecture, we'll talk about data synchronization and grain sizes. I'm Ryan Baker. This is Big Data in Education. See you next lecture.